In the lesson 2.4 example, what's the correlation between foot length and height, we'll practice calculating correlation. This table shows the foot length in centimeters and the height in centimeters for a random sample of 6 high school seniors. Calculate the correlation for these data. In the previous lesson, we learned how to estimate the correlation between two quantitative variables. Notice in this scatter plot, there's a fairly strong linear positive relationship. So our estimate of the correlation R is going to be positive and close to 1. To calculate R, we'll need to go through several steps. First, we'll need to find the mean and standard deviation of the X values and the mean and the standard deviation of the Y values. Then we'll need to calculate the Z-score for each X and each Y, find their products, add them all up, and divide by 1 less than the sample size. So let's go through step by step. The mean and standard deviation for the foot length in centimeters are the mean 23 and standard deviation 3.95 centimeters. The mean and standard deviation for the height Y are 168 centimeters and 15.54 centimeters. Now we'll use each of those to find the Z-scores. Now recall, for the Z, we'll take each observed X value minus its mean and then divide that by the standard deviation. So for the first observation, the foot length was 23 centimeters. So we'll take 23 minus the average foot length, 26 centimeters, and divide by its standard deviation, 3.95 centimeters, giving us a Z-score of negative 0.76. We'll repeat that for each observed X value, finding each Z-score. Then we'll repeat the process for each Y value. So for the first observation, we saw a height of 167 centimeters. So 167 minus the average height, 168, divided by the standard deviation of height, 15.54, gives us a Z-score of negative 0.06. Again, repeat that for each observed Y value to find each of those Z-scores. For the third step, we'll multiply each of those Z-scores to find the product. So for the first observation, negative 0.76 was the Z-score for the X, negative 0.06 was the Z-score for the Y. Multiplying those, we have the product 0.0456. Finally, we add those Z-score products and divide the sum by n minus 1. So taking each Z-score product, we'll add them all up. N, our sample size, was 6. We'll take away 1. And we get a correlation of 0.84. Now that matches our original estimate in that it's positive and it's fairly close to 1 because this was a strong positive linear relationship. For additional practice finding the correlation, try exercise 1.